de Giovanna VASCO. Donc elle est en post-doctorat, financée par la Fondation des sciences du patrimoine. Et donc elle travaille au C2AMF au sein du groupe peinture. Donc je vais lui céder la parole et cette fois-ci, je vais partager sa présentation. Je ne vais pas me tromper. Alors, excusez-moi, hop. C'est un peu compliqué de devoir changer à chaque fois. Je suis sûr qu'il y a une méthode plus simple. Elle est où ta présentation? Elle est là. Ok. Donc, est-ce que ça marche? Oui, ça marche. Parfait.
Ok. Hello everyone. So I will present the preliminary results of the East Blue project. So as Kilian said, it is a project funded by FSP. And it's still an ongoing project that I started on April, and it has been realized between the Bibliothèque Nationale de France and the C2RMF. Its main aim is the analysis of the inks the prints realized in Fontainebleau and Paris in the 16th century that today belong to the Department of Prints and Photography of the BNF. We have also involved other partners, so the Circe and Monaris, that have kindly lent us some equipment, respectively a Broadband multispectral imaging setup and a Raman spectroscopy device. So the Fontainebleau Castle is located 60 kilometers southeast from Paris, and it's a UNESCO World Heritage since 1981. So it was built in the 12th century, but it underwent different renovation works. For instance, also during the 16th century, when the King Francis I wanted to set at the court of Fontainebleau a representative cultural center for the French Renaissance. But we must step back for a while over time and space. And in the 15th century, Mantegna was a pioneer artist in Mantua, also dealing with the production of engravings. And several decades later, Rosso Fiorentino and Primaticcio were two Italian artists that were called by the King of France to lead the School of Fontainebleau. And at that time, Primaticcio was in Mantua, so it is believed that he might have been the one that brought 9 copper plates realized by Mantegna in France. Thus also producing French copies after Mantegna. So Rosso Fiorentino moved in the 1532 leading this Italian-French-Flemish team. And after his death, he was replaced by Primaticcio. And soon after, just in 5 years, so between the 1542 and the 47, there was a huge production of prints in Fontainebleau, including woodcuts, engravings, and etchings. But after the king's death, the artists spread all around. Some of them moved to Paris with their own printmaking centers. So we must also highlight the difference between the two different techniques, so engravings and etchings. So in engravings, the artist scratches the design directly into the surface of the metal plate with a sharp tool called burin, while in etchings, there is a layer of acid-resistant varnish or wax that is scratched by the artist, thus exposing the metal plate beneath. Then the plate is dipped into an acidic bath that erodes the exposed metal, thus transferring the design. So, of course, we had several questions, but due to time constraints, we will see just a couple of them. So we were wondering if there were the different inks used at the same time on the metallic plate to produce one print. And also if it was possible to see different trends depending on artists and locations. So we did a selection of the prints, including 6 6 prints from Mantegna's plates. 2 of them realized in Italy in the 15th century and the other in Fontainebleau. 16 prints from Fontainebleau, so we must consider that these prints are all monochrome prints, but some of them have been realized also in different colors. So that's why we have included 3 groups, so black, brown, and red inks. And also 8 prints from Paris in black. So regarding the analytical workflow, we have followed 2 main steps. So the first one with the imaging methods using broadband multispectral imaging in order to look for possible different inks and their distribution at large scale, but also different digital microscopes in order to see if there were mixed inks at microscopic level. I also transmitted infrared images in order to check the paper provenance, while the second step consisted of spectroscopic methods to get complementary information on the inks using gamma spectroscopy, possibly for carbon black and iron gold inks, fiber optics reflectance spectroscopy for the possible use of pigments, and X-ray fluorescence in order to get elemental information on the inks. Regarding the transmitted infrared images, it was possible to differentiate between the Italian paper and the French ones. So we can see, for instance, that Fontainebleau was characterized by the presence of a group with a small circle, but there were also watermarks that were shared both by Fontainebleau and Paris. For instance, some shields belonging to a family of paper makers in the Grand East region in France, but also from the same place, other shields, and the use of the French modeling. So regarding the first question, if there were different inks at the same time on the metallic plate for one print, as we can see from the image in the center, so the false color image, apparently the ink was the same because the image was quite homogeneous, excepting for this print in which we can see a darker frame and a lighter landscape. And indeed, there were different compositions using XRF. So the frame was mainly consisting of iron-based materials with also manganese and the presence of copper, while the light landscape was mainly made with iron and phosphorus, so bone black. However, at microscopic levels, we could see different particles, so shiny particles, red particles, possibly coming from the use of also red inks from the same plate, and also aggregates. And this was true for all the prints. So despite they appeared homogeneous, they were consisting of different compounds. As we can see from the infrared images, in which we had carbon black that retained its opacity, while the iron-based materials become mainly transparent in this range. So regarding the first question, using XRF, I saw generate aluminosilicates, ox, consisting also of several elements, for instance, manganese, bone or ivory black due to the presence of phosphorus, white lead in the lighter background, but also zinc and copper. And as we can see from this spectrum, copper cannot be considered just as a trace. So I presume the presence of vitriol together, of course, with iron, titanium, and sulfurs. So all the prints had more or less the same compounds, so the same elemental information, but in different amounts. For instance, for some of the black inks from Fontainebleau, there were more metal-based inks with respect to Mantegna that was higher in bone black. There was a slight variation of the same elements for the Parisian group, and of course, red and brown inks had the highest amount of iron and the lowest of phosphorus. So how can we find different trends? So by maximizing the variance using PCA. And indeed, we can see a separation of the blue etchings from the Fontainebleau engravings after Mantegna that were mainly related to iron-based compounds, so possibly to have a more brownish black ink. While there is a slight differentiation between Paris and the Fontainebleau etchings, mainly related to the content of calcium and sulfur, so from calcium sulfate, possibly used as an extender. Also copper that might have been used with the metal-based inks as dryers. And also some different content related to phosphorus. And if we relate this data with the different authors, we can see that there are specific clusters. Even if in this case we cannot really say if there was the use of specific recipes or if it was just the use of the same batch of ink in a short time, considering also the huge production in Fontainebleau just in 5 years. But applying the canonical analysis, it is possible to have another data set with linear combination for maximized correlation. And we can see an overlapping of data as in the PCA for Fontainebleau and in Paris, but it is possible to differentiate very well the Fontainebleau Mantegna and the Italian Mantegna. Finally, regarding Raman spectroscopy, it is possible to see different categories of carbon black by the convoluting the disorder bands and the graphitic band. However, as we can see in my data, there is a central peak that corresponds to iron gold ink. And indeed, if we look at the residual data, if we have a random pattern, it means that we have deconvoluted all the hidden peaks. So we can see that it's not a random pattern. There are some other peaks that are overlapping between the disorder bands of the carbon black and the bands from iron gold ink. And applying PCA, we can see a different use of carbon black and iron gold inks related to the different groups of the prints. So basically, for instance, the second component is mainly related to the absence or the low content of the iron gold inks. And for instance, we can see that partially the Mantegna Fontainebleau and the Fontainebleau prints have less use of iron gold inks. While a higher use of iron gold was related to the Parisian group. So we found the same ink on the same plate, but with different components. There were different trends in the ink composition, even if there was an overlapping of the Fontainebleau and Parisian prints. So regarding the other questions, we found that there was the use of the same metallic plate with different colors to produce different monochrome prints. And also we have found different clues about the workshop, in particular the drawing transfer and the shard of the same design between the artists. So since it's an ongoing project, currently I'm here at the C2RMF performing the confocal Raman spectroscopy, and I will do micro XRF and XRD quite soon in order to look better for the oaks and the presence of carbon black and metallic inks. And of course, I want to thank the FSP for the fundings, all the partners involved, and also I want to thank other institutions that have contributed to sharing their knowledge or suggestions.
Merci Giovanna. Est-ce qu'on a des questions dans la salle? Non, il est encore trop tôt ce matin. Est-ce qu'on a des questions en ligne? Est-ce que cette fois-ci vous avez vu la présentation? J'espère que oui. On attend de voir s'il y a quelqu'un qui répond. Peut-être tout le monde est parti. One question maybe about the use of iron gal ink in this print. This is something odd. What is the hypothesis you think explains the use of this mixture of ink, iron gal ink and carbon black ink for this print in Fontainebleau?
Okay, so it might be odd from a first sight because, for instance, the use of iron gall inks in miniatures has already been proved, but not so much about prints. I think that it's because there is an overlapping while applying XRF. Regarding the presence of iron-based compounds, but it is possible to see it using Raman spectroscopy, especially by deconvoluting the bands. Possibly there was the use of iron gall inks as well, not only in miniature, but also in prints. So possibly the use might be related, for instance, to the sulfur content, especially regarding the oil binder. So to dry it faster. But I really think that there will be further studies about it, because, for instance, it wasn't really attested from recipes. So there is a lack of recipes about that. Lots of groups have found carbon black. But as I said, applying XRF, it is not possible to see them. That's why I proved it through Raman spectroscopy after having looked at the content of copper, because it was mainly related to the inks, not only from the background. So we must exclude it as a trace element from the residuals from the copper plate.
So the methodology is really important in this case.
Yeah.
Okay. And how do you explain this difference between the print of Mantegna in Fontainebleau and the rest of the print in Fontainebleau? Do you have some hypothesis about this difference in the ink?
Possibly regarding the pattern of the PCA, it seems that they had the same idea about the components that they had to use for the inks, but that finally they used in different amounts. So it was like they were specializing a bit. So of course there was a shared knowledge. As we can say, there was someone that brought the copper plates to France. Possibly he knew also something about how to produce inks. And then there was a different trend, but it might have also been related to a different taste. Because, for instance, of course, the presence of iron compounds is also related to a different shade of the ink. And as we can see from the Parisian prints, they are really black. So it also might be related to an aesthetic choice.
Okay. On a des questions dans la salle? Non, toujours pas d'inspiration. Est-ce qu'on a des questions en ligne? Ah, une question. Could you identify bone black using Raman?
Yeah, so as I said, it is possible to find different carbon black typologies using Raman by checking the convoluted bands. So also in my previous studies, I specialized in carbon black. So depending on the presence of the number of the disordered bands and their position, it is possible to see also in this case that it's bone black. Even if it was not possible to see the band at 900 something related to the phosphate, but also depending on the presence of the binder and the binder typology, it's not always possible to see that peak for carbon black, for bone black in carbon black. But we can say that it's bone black from the typologies of peak and their position regarding carbon black. And of course, there is the complementary information of XRF with the presence of phosphorus.
Thank you, Giovanna. On la remercie.